here the value is 1. Before that, if the value is 0, then we can able to tell that the signal is changing from 0 to 1. So we are telling this as positive edge. If the last value is also 1, now the value is also 1, we can't be able to say that it's a positive edge because it is having a stable one. Before also 1, now also 1. Here there is no transition happen. The value is same one here and same one here. Okay. Here the positive value, last value is 0, 1. Now the value is 1. That means it is going like this. So here this is a positive edge. No, right? Here it is a negative edge. Why? Because it is falling from 1 to 0. If it is falling from 1 to 0, it is negative edge. If it is rising from 0 to 1, it is a passage. So here we need to check that value of the whether it is a positive edge or negative edge for a signal. So in order to check for that, we need one clock signal. Okay. In that positive edge of the clock only, we are going to check the value of the signal. For that, we need one clock. Then this clock is the input. Then we need to generate some pulse output. Okay. Whenever the signal becomes whenever the signal is transiting from 0 to 1. So for that, if it is transmitting from 0 to 1, then we need to make this positive edge as 1. Okay. Then edge delay underscore signal. So in order to sample this signal, I need to make a decision whether it is a positive edge or negative edge, or it is a stable 1 or it is a stable 0. I need to check for the last signal value at the before clock edge. If it is 2 o'clock, here the value of this signal, okay, signal is 1. In order to tell whether it is a positive edge or negative edge or stable 1 or stable 0, I need to check what is the value of the signal previously. Then only I can able to tell, right? First, can you able to understand what is the positive edge, negative edge, stable 1 and stable 0? Can anyone tell me what is the positive edge?
Positive edge in the sense like at every passage of the clock, it should trigger.
It should trigger means it should transit from 0 to 1,
0
right?
to 1. Yes, yes.
Yeah, negative means
it should fall like at every negate of the clock, should fall like 1 to 0.
1 to 0. Negate means 1 to 0. At every this is based on the signal. Okay, 1 to 0. What is stable 1?
It should stay like input side. I mean, only 1 to 1. Like it should constantly stay.
Consider this is the clock. In this positive, here I am checking for every positive edge of the clock. Okay, here when the first positive edge of the clock happens, my signal is at the 1. Okay, in the next positive edge of the clock, if the signal is at the same 1, we can say that as stable 1. From the past positive edge to the next positive edge, the signal to be remains stable at 1, we can call it as stable 1. If the signal, so here after this, here it becomes 0. Okay, it comes to 0. So here it is at this positive edge of the clock, it is 0, right? So here it is 0. So in these last 2 clock cycle, it remains as 0. So we can say it as stable 0. Okay. In order to check whether the signal is positive edge or negative edge or stable 1 or stable 0, we need to have that last value, past value of that signal in order to compare, and we need to in order to make decision, we need to compare that value of the signal at this positive edge of the clock with the signal value at the previous edge of the clock, right? Then only we can able to determine whether it's a positive edge, negative edge, or stable 1 or stable 0. So here what I am going to do is I am using one edge. Here I am delaying the signal. Okay, here the signal, the positive edge of the clock is like this. Here the signal is like this. Okay, here I am writing, here I am delaying that signal. The signal value will become like this. It will delay that signal to the one positive edge of one clock. So always here, what is this assignment? What is this assignment is called as?
Non-blocking.
Yeah, non-blocking. What does this assignment will do? Non-blocking assignment, what will do? What will it do? How it is differ from that equal to?
Like non-blocking in the sense, it will schedule after the without blocking any execution.
Yeah, it won't block the execution of the next statement, but whatever the things which are present at the RHS, it will compute those, and it won't assign it to the LHS. It will assign only at the end of the time step. Okay. So if A equal to B, B equal to A. So here the A value is 5, A equal to B equal to 10. If I am using A equal to B and B equal to A, what consider A equal to 5, B equal to 10, then tell me what will be the value of A and B after the execution of these two statements. A, the value of B is nothing but 10. That will be assigned to A, right? So after that, then that 10 will be assigned to this B. So A equal to 10 and B equal to 10. So both will have the same value 10. Okay. Whenever if it is a blocking statement, what will happen is it will compute this and RHS and will assign to this only at the end of the time step. Okay, if all the non-blocking statements are there, for all the statements, it will compute these RHS and it will put that value into this LHS only at the end of the time step. So here, what will be the value of B? B will have the value of 10. A will have the value of 5. It will store this 10 and 5 into some other temporary variable, and it will put that value into the LHS only after the time step. So here this 5 will be assigned to this B, here this 10 will be assigned to this B. So A will have the value of 10 and B will have the value of 5. So here we are swapping that number. Okay. So by using this, what will happen is here this delay signal will always have the previous value of this signal. Okay. So if it is here, I can be able to. Here for every questions, I am taking some huge time only. So by telling the answer for every questions, that won't help you much. So if you understand one or two questions deeply, then you can able to solve any other question similar to the question which we solved, right? So that's the reason I am spending much time in each and every question. So this is the signal. Okay. Here I am assigning that signal using that non-blocking to that delay signal. So what will happen is here it is low. So here it will have that same low. Here at the positive edge of the clock, it is rising, right? So it will that rising will be applied to this delayed signal only at the next positive edge of the clock. So it will become like this. here at this positive edge of the clock it is dropping. So at the next positive edge of the clock it will drop. Okay, like that the signal which is present will be always delayed with this signal. So by comparing these two, now we are going to tell whether it is a positive positive edge, the positive edge of the signal is a happened or not. Okay, so here if the delayed signal will have the last value. Okay, so here this delayed signal should be 0, then it should be 1, right? Then only we can able to tell that this is rising edge. Can you able to understand what I am telling? So
Yes, sir.
whenever the delay signal is 0 and the current signal is 1, then the pulse should be high, right? That means the delay signal will have the past value of the signal will have the present value. So if the past value is 0 and the present value is 1, then we can say that the positive edge has happened because it has transited from 0 to 1. So in order to assign this, I am assigning signal and not of delay. So whenever the delay is 0 and this is 1, then the pulse should be 1. So for that, I am using signal and inverse of delay underscore signal. So this will give me the pulse whenever the positive edge happens for the signal. Okay, can you understand this question? Can I move to the next question?
Yes, sir. Understand.
Sir, I have one doubt, sir.
Yeah, sure.
Sir, how you are assuming that this delay signal will always be 0, sir? For going to the detecting the any pauses of any signal, the previous signal, that is your delay signal, should be 0. The next signal should be 1. So
Yeah.
for assigning the pulse, your signal should be 1 and delay signal should be 0.
Yeah.
But if the signal is going to be previously 1 and this delay signal is also going to is 0, then
So
in that case, sir, it is always 1.
Here what I am doing by this, what are the possibilities? We are having signal and delay signal. Okay.
Yeah.
Delay. I will write the delay signal. Okay, delay signal. Okay. So what are the possibilities? 0, 0, 0, 0, 1, 1, 0, and 1, 1. These are all the possibilities, right?
Yes.
Okay, if the past value is 1 and present value is 0 and 0, whether it is a pulse positive edge, it is a stable 0,
Yes.
right?
Yes.
So the output should be 0. So last value is 0 and the present value is 1. Then what will be the is it a positive edge?
Yes, it is.
Yes, it is a positive edge, right? So here it is the last delay value is 1 and so it is negative. So here also 0, right? So here 1 and 1. So it is stable 1, here also 0. So for these values, the only thing is here I am going to make this as 1 pulse. Here in order to check this, you need to do the K-map and all, right?
Yes.
Yeah, you need to do that K-map and all. But here it is only, here only the value of 1. What is the possible input for that? It is 1. It is here, it is a delay. If it take this as A, this is B. Here it is A bar and B. Okay. If it is A bar dot B, then only the output should be 1. Right?
Yes.
Yeah, that's why here I am, this is A, this is B. So I am taking that B into A bar.
But sir, this delay signal could be any unknown also, sir. If it will be in the unknown state and then it is moved to X1, then also we call it as a pause.
Yeah, if it is you are telling about the unknown stage, right?
Yeah.
Unknown to 1. But here we can Yeah, but practically in this positive edge, we can be able to detect that whether it is X or not. Okay. So in this, it is a simple program. In this, we are just checking whether it has raised from 0 to 1 or not. Okay.
Uh,
So write a constraint. Write a constraint for random. The meeting is for how many hours? Are you guys feel bored? If you feel bored or we can continue 15 minutes. It's purely based on your choice.
Continue, sir.
Yeah, okay. Write a constraint for random. Yeah. Okay, write a constraint for randomly generating an array number with a size of 20. Here, short that they are telling that array should have the value of 20. Okay, that should have the value of number of size of the array should be 20. Sort in ascending order without using the inbuilt sort method, and the sum of all arrays elements should be equal to 300. Tell me how many constraints are there we need to write for this question. How many constraints are there? This is the one constraint, array of size. This is the second constraint, inbuilt method. Without using inbuilt method, that should be ascending
and the
order. Then
third is for the
this is the
sum of the elements.
sum of the all the array elements should be 300. So these are all the three constraints we need to write. Okay. So can you tell me the solution for the first constraint? Two slides before only we have done this same question, right? Array of number size, array of size. Okay. Size of an array equal to 20. This is what they are asking. For that, what is the solution? Let's take array. Okay. I'm taking int array. Int array. How to write a constraint to generate an array size of 20? Two slides before only we discussed, right?
Array dot size, sir.
Array dot size. First constraint is done. Then telling that in the array values, what the thing I need to use for each of a of here array, right? Array of I. Okay. For each of array of I, in that I need to check a of I. If it is a of I is 1, then a of 0 is what? A of 1 is a of I. Then a of 0 is what? A of I minus 1, right? Here a of I is 1, then I minus 1 is what? 0, right? Right? Can you able to understand? Or else can I need to repeat again?
Understood, sir.
Yeah. So for a of 0, a of 1, a of 2, and a of 3. Okay. Here if the value of 3, here it is 10, here it is 15, here it is 28. So if it is a of I, That means take a of I as 1. If it is before a of 0, then a of I minus 1, right? So here if it is the value is 5, here a of I is 5, then it should be 3. That means this a of I should be greater than, right? So if it is less than, then it should be greater than that value, right? So for each of array of I, that a of I minus 1 is greater than a of I. Okay. So this will gives me the ascending order. But the only thing is it will iterate to the here if the array of size is 20, then the value is 0 to 19, right? The size of the array, the index of the array is from 0 to 19. So that means it will have a of 0 to a of 19. So this for loop will iterate from 0 to 19. Okay. So if the value substitute for every value, we need to substitute. If a of I is for first I equal to 0. For I equal to 0, 0 minus 1 is equal to 0 minus 1, right? So is that minus 1 is available in that index?
No, sir.
No, right? So if I am using this, it will give me a error that you are trying to assign some value to the index which is not actually present, because the a of minus 1 is not present actually. So we can be able to assign any value to that index. So we need to give some constraint that I should be greater than 0. For I equal to 0, we should not use this constraint. Only when not to compare to value, I need two value, right? So when it is at the 1, then only I can be able to compare with 0. If it is 2, then I need to compare with 1. Like that, till I can be able to compare with the 19th index. For that if I should be greater than 0, that means if it is 0, then I am not comparing this. Whatever the value which is present in the a of 0 is okay. After that only I'm here, there is no constraint for me to put this value, that value, but only constraint they are telling is that value present next to this a of 0 should be greater than this value. If it is 3, then this should be above 3. If it is 10,000, then the next value should be above 10,000. This is the only constraint, right? So here I am using I of greater than 0. Then it will give me the ascending order behavior. Okay. So then they are telling that sum of array should be 300. That means if you add all the numbers, a of 0 has some value, a of 1 has some value, a of 2 has some value, right? If you element, if it is 3, 5, 8, like that, a of 19, till a of 19, each array element has some value. So based on that value, if you add all those values, that will gives you 300. Did you have any solution for that? There is one predefined or inbuilt method present for the array to count that number of elements present inside that. Now to find the sum of arrays, which is nothing but array dot sum equal to 300. So we have written 3 constraints. So this is the third constraint. First constraint is nothing but array dot size. Then the second constraint is for each array of I. Okay, inside that a of I minus 1 should be less than a of I. This should be happen only if the I value is greater than 0, right? Do you all understand this constraint? So if you by using these 3 constraints, we can able to array dot sum equal to 300, size equal to 220, then I is greater than 0. By using these three constraints, we can for whatever the value which I am randomizing, the array of size should be 20, and for every value should be greater than this. Okay, if it is 8, then it is greater than 80. If it is 80, then it is greater than 96. This is this is how we need to write the constraint for these types of questions. Okay. So before we will end this meeting in 10 minutes. Before that, I will give you some overview of some of the questions which will be asked based on the functional coverage and the code coverage. So what is, can anyone tell me what is code coverage? Can anyone tell me what is code coverage? What are all the things which are present in the code coverage?
So code coverage means it will give you the how much percentage of the code that has been written for that particular program has been covered. Means
Yeah.
how much
Code coverage will tell us how we as a verification engineer, we need to verify the RTL code. In the RTL code, there will be consider there will be 200 lines. In the 200 lines, the RTL design engineer write all these 200 lines of codes only for the with some intention. They won't do any lines without any intention, right? So if the RTL engineer written some line, there should be some use case for that should be have some use cases for that program. That's why the RTL engineer write that code in that program. Okay, so if if the code coverage is 90 and the functional coverage is nothing but the coverage which the verification engineer needs to write. So here we need to do that functional coverage based on the features of the design. So let me take one simple memory, okay, or FIFO. We will take that FIFO. In that did you all aware of FIFO, right? First in FIFO. Let's take a simple memory only. Okay, let's take that memory. In that memory, what are all the features we can write? We can read to all the addresses, right? So here the what is the if write underscore read, okay, mem of address. I'm going to write data. Else read data equal to mem of ADDR. Okay, here if the write read is one, that means write is happening. Then I am going to write that write data into the mem of address. If it is a read data, then I am going to put that data by using this is the RTL code. I am going to verify this code. In order to verify this code, I need to have the functional coverage and code coverage. In the code coverage is generated by the code coverage is generated by the tool itself. Okay, so the functional coverage is the thing which I am writing. Okay, so sometime what will happen, I will ask you some questions. Code coverage is 70%, code coverage is 100%. What is the issue? That means if the code coverage is 100%, that means this line, this line, this line, this line, all the lines has been executed, but my functional coverage is 70% only. That means what I need to do is I need to increase the stimulus to the design. That means here I have written, I have write to the memories, but what I have done is my address is 3 down to 0. Okay, that means 4 bit, that is 0 to 15. Okay, what I have done is I have written into the 0th address, then I have read from the 0th address. If I done this for only one time, this all the lines will be executed. So the code coverage will become 100%, but the functional coverage will be less, right? So if I write into the memory, this will be executed. If I read from the memory, this will be executed. So all the lines will be executed. Then my code coverage becomes 100%, but the functional coverage will be 70% or 20%, less than 20%. That means I need to give some more stimulus. Okay, this is the thing. And if the code coverage is high and the functional coverage is less, then I need to give some more stimulus to the design. If it is ulta, if the code coverage is 20 or 70, my functional coverage is 100%. That means sometimes I will miss that some of the features. Let me take the FIFO. What are the FIFO features present in the FIFO? Write, read, then full error, okay, empty error. Okay, I missed that empty error and full error in the functional coverage. So I didn't verify this. By verifying this write and read, my functional coverage becomes 100%, right? But the code coverage in the code and the program, there will be a line for this full error and there will be a line for this empty error. So these two lines doesn't executed. But I didn't include this in the functional coverage. That's why the functional coverage becomes 100% and the code coverage is less. So that means I missed that some of the features of the design. I need to include that in the functional coverage of my test bench. Okay, this is the two different questions asked based on the functional coverage and the code coverage. I think for this session we have done with some of the questions. Can someone give some feedback about my teaching, my explanation? Is it useful for you? Is my teaching is understandable?
Yes, sir, it is very good.
That's all for now. Thank you.
Yes, thank you.
Yeah, thank you, sir. Thank you, guys. Thank you so much. Thank you, guys.
Okay.